Welcome to qnawire.
Okay, so we're in chapter 29, problem 11 here. So it says a circular loop in the plane of the paper lies in a B of 0.75 Tesla, a B field, and it says it's pointing into the page. Okay, if the loop's diameter changes from 20 centimeters to 6 centimeters, so D initial is 20 centimeters, D final is 6 centimeters in a time span of half a second, it asks us some questions. So A, what is the direction of the induced current in the loop? Okay, so as the diameter decreases, the area decreases. So phi b is just given by BA. So for a constant magnetic field into the page, that means we have a d phi that is decreasing into the page. Okay, so that means we want to find which direction the current will produce a B field that opposes this change. So that means the B induced to oppose decreasing into the page needs to be into the page. What way produces an into the page B field? You see that as a clockwise current. So that's our answer for part A. Part B now asks, what is the magnitude of the average induced EMF? Well, we can just find the average here. The magnitude is just by the change in magnetic field over the change in time, or change in magnetic flux over the change in time. Well, the magnetic flux is just pi r squared times b, so this becomes b. We have pi d final over 2 squared minus pi d initial over 2 squared, all over delta t. So what we get here is 0.75 Tesla times pi times 0.1 meters squared minus 0.03 meters squared, all over 0.5 seconds. So we have everything in SI units here. So this answer is going to come out as an average EMF of roughly 4.3, oops, that was a terrible 3, 4.3 times 10 to the negative 2 volts. Cool. So that was part B. Let's see if we can fit part C in here. What does it ask us? It says if the coil resistance here is equal to 2.5 ohms, what is the average induced current? Okay, well, the current here is just given by the EMF over R from Ohm's law. So that's 4.3 times 10 to the negative 2 volts over 2.5 ohms. And we get an average induced current of, all right, average here, 1.7 times 10 to the negative 2 amps. Cool.